Thank you very much, Saul, for an extremely inspiring talk and how you managed in 45 minutes to put everything. I'm flabbergasted. So, in questions, waiting for questions and raising of hands. I would say I wanted to add that very recently, not very recently, a few years ago, I discovered, I mean, when you had this metaphor of the raft versus the pyramid, that even Plato has, or that is considered the guy that said the absolute truth and then everything else is a corruption of it. He has big passages that he calls the second navigation, Δεύτερος πλός, which says, when the wind stops, you go to the oars and you start to row and navigate into the wild sea. And, science, I mean, and then you still have to have very interesting tools to survive. And this I find, this joins that. So we have one question by Giuseppe. He says, you were talking about material developed with the Nobel Foundation. Is that available?
Well, its intention is to be completely free and available for everyone. Right now, it's in the pilot phase where we're just testing. We're testing the first material. It's a lot of material. There's I think 150-page student manual and maybe 200 and something pages of teachers' manuals to help the teachers understand what to teach. And what we're so if anybody wants to participate in that pilot of giving feedback on what was that the first material look like, then we're certainly glad to talk and try and make it available. The goal, though, is to do an iteration of it, as I described, iterative work, and to have a better version that is more polished with nice graphics and everything, that we will make available on the Nobel Prize websites. And my guess is it'll probably be the first couple of modules. We're imagining something like 6 to 8 2-week teaching modules that will be available that people can use in different courses. They could use these different modules, or they could put them all together in one. And the current thought is that we'll have the first couple of those modules available by basically a year from now for the fall. And then others will come out over the following year or so.
I'm in physics education, so I basically feel addressed that we've got to do something here. And I would love to see the material you've developed for high schools, but because we have programs for high school kids, and we have PhD students working on how to bring critical thinking into high school classes, because I think we have to address 21st century skills in schools, because this is very, very important when thinking about what we want students to know and what competencies they should have when they go to their jobs, like 15 or 20 years later. And we definitely got to prepare them. But what I wanted to ask you is, of course, if it's possible to have a look at the material. And can you tell us, your university class, how long it took? Because Marek and I had the first pilot study of a seminar we were doing, and we only had a 2 hours per week time, and found that we were somehow overextending students' abilities to go through all these topics, because that's where the prior knowledge about how the nature of science, how physics works, and the prior knowledge about styles of scientific reasoning, and all the things were quite a lot for the students, to work through before a really good and interesting discussion could be made. So I was just interested in how much time did you spend with your university students on each of the topics?
So the university students, that version of the course, we at Berkeley, we have it's a fairly long semester. So it's a 14-week semester that we have. And we would be teaching it basically there's two different versions we did. We've done a version that's entirely in class, and we've done a version which is a flipped classroom where we have material ahead of time, and then they do a lab, and then they come and meet the faculty afterwards. The original version was essentially 3 hours a week, and that was broken down into 2 hour-and-a-half sessions, and each hour and a half would do one of the topics. Occasionally, every now and then we do two, but basically we would do a topic in an hour and a half, and that included some back and forth with the faculty talking, some activities and exercises, some discussions, and I would say that it always felt you had to work hard to keep the timing working and to make sure you covered all the activities and all the different topics you wanted to have discussions on. But we could just fit in an hour and a half for a topic. Was very typical for us.
And sorry, were these students with prior knowledge in physics, or did they come from?
No, actually, this is for a group that was all 4 years of the university at Berkeley, and all fields, so that we had maybe 1/3 humanities, 1/3 social science, and 1/3 natural science. And we tried very much to keep the focus on the ideas of these concepts, and not on, for example, mathematical applications, for this group. And that seemed to work for the whole group. The natural scientists, some of them already knew a few of the topics, but often not. I mean, I'd say that a lot of these topics, like for example, as describing about probabilistic thinking and or blind analysis, things like that, they later learn them when they start doing research, but they've usually never learned them in any courses. So for them, it was new, just as it was for the philosophy student and the English student. Yeah.
Thanks.
Didier?
Yes, I have maybe some somewhat philosophical question. Suppose we find in another country or even on another planet another civilization who do you think that they would, with a different culture, do you think that they would have different theoretical models with different interpretation of the experimental data? And another question would be, do you think that they would have a different critical thinking, or is it something more universal?
Now that's a fascinating question. I will say that in this year's version of the course, one of the things that we were trying out coming round is a little bit more emphasis on the difference between that shared reality out there and all the models of the shared reality that we use. And we there you can point out that the every model of the reality out there is usually built for a slightly different purpose. Sometimes we use a map to describe where everything's located in the world. Sometimes we need use mathematics to describe things that are out there in the world, and that most, in fact, no model is a complete description of the world. And I do think that if you have a very different culture and for that matter, an alien intelligence, the things that you will need to model of what the reality is are likely to be very different, and the model will look very different. But what we want to emphasize is that it's not that the world out there is different for you and me and the alien. It's that the model that we use to describe the world is different, and that we still want to often bring the models to compare to each other if that's one of the better ways to recognize where we've got something wrong about the world out there. So I think that's actually a very interesting starting point, that people recognize that the models that we make of the world can disagree or can look different, and they can also be sometimes just practically different because you're using them for different purposes. But that you're still all trying to get some handle on a reality out there that is going to be the same for you, for me, and for the alien. Now, in terms of the methodologies of critical thinking, I think it's a fascinating question. as well. I suspect that some of the ones that we're teaching are just particular to our own tendencies, the ways in which our mental models and our brains tend to make mistakes. And we learn new ways, as I was saying, that we go wrong. And that some of them, I think, are very specific to our culture, the ways that we make mistakes, and we have to learn how to be critical and avoid them. I do suspect that there's a couple that are pretty fundamental. I mean, the idea that it's helpful to recognize that your understanding of the world is correctable, it's tentative, and that you will get better and better, ideally, but that you don't necessarily ever say that your model and your picture of the world is correct, at 100%. It's, maybe getting that this aspect is getting to be 99.99% unlikely to be right. I suspect that kind of probabilistic take on the world might be something that any intelligent life would need, because I'd be very surprised that if any intelligent life would be able to get direct access to what reality really is. And so they'd always be playing that game of trying to improve their understanding of the world. But that's just a guess, of course.
Thanks for your answer and for your presentation. I think that critical thinking is very important to share.
Let me just add, I see the question of whether somebody might be able to get hold of material earlier before the finished product. And I think if there's interest in just being one of the test, the test locations that tries out the material, I think it would be possible. So certainly we could get in touch, and try to try that out as well. And that's for the high school. That's for the high school version. For the university version, we also have all that material available, and we are very happy to share it with any university faculty who want to try to teach.
I would say that your website, I mean, the syllabus is very complete. It's 100 pages, so something. Yeah, I mean, to get inspiration for a long course. Yeah, I don't know. I'm sorry. Go on, please.
Oh, I was just going to add that I believe that, let's see, this website that I just put in the chat, that has all the topics, and it's one of the places, it's one of the launching points for faculty to see what we're doing.
So we're approaching the hour that we said that we occupy Saul, and I think it's been a very exciting hour. I wanted to say a few words about our sponsor, which is the European Union program Reinforce on citizen science. I didn't want to tire you with this, where we produced what we call demonstrators of gravitational waves, so that the citizens characterize the glitches that we see, whether they are noise or they are signal. I mean, all of the things you have, you have seen. And, but this, and also in the deep of the sea, the kilometer cube, but the neutrinos, cosmic rays, and also at CERN. I didn't want to mention that this program is ending at the end of of November, so in a month from now. So probably I've seen the interest by Giuseppe Levi and other people, and you just mentioned it. So I think that we can be the hub, my mail can be the hub, that we concentrate, I mean, just gather the people that would like to make similar things in different European countries, and A, of course, be in contact with Saul, B, eventually try to propose something to the European Union to get also some funding for all this. That's an idea that just came because I saw the interest of people for these courses. So we can be the hub, but we don't want to be the coordinators, just gathering since we started that. And so thanks again, Saul. Thanks again very much for all this. And we start, as you know, from the website in 2 days from now with Stefano Gattei, our tentative of the same thing. So, is there anybody else that would like to say a final word? Otherwise, in 1 minute or two, we'll just close and thank again. No. So you're muted, so yeah, please. So you're muted.
So I was just going to say thank you for organizing, Stavros. It's a pleasure to join everybody, and I'll look forward to hearing about the whole week's discussion that you're about to start.
Yeah, it's fantastic, fantastic. I think. I mean, I've learned so many things in 1 hour. Very good. Okay. So bye everybody. Thank you, everybody. Thank you everybody for participating, and it's just the beginning.